Hello everyone, and welcome to Week 4 of Robotics for All's Advanced Python class. This lesson we're going to learn about stacks and queues. Stacks and queues are data structures that work like a container of objects, just like a list. They follow two different principles. So the stacks follow the last in, first out principle, referred to as LIFO. Basically, imagine a stack of coins. If you add a coin to the stack, you're going to place it on top. If you remove a coin from the stack, you would take it from the top as well. This is the same principle that stacks use. The coin on the top is the last coin you put in the stack, and it's also the first one you take off. So if you look at this diagram of a stack here, it works exactly the same way. When you place an item into the stack, that item is also the first item you remove from the stack. Now, queues follow the first in, first out principle, referred to as FIFO. This is like a line at a supermarket. The first person in the line is also the first person to get out of the line. Again, the difference between stacks and queues is that the stacks follow a last in, first out, while queues follow a first in, first out. Now, why would we ever use stacks and queues over arrays and lists? The main reason is because it is more efficient for memory utilization, which we'll go over more in week 7. We also like to use tools that are most relevant to what we are doing. Using stacks is ideal for situations that enforce that LIFO principle, and queues are ideal for situations that require enforcing the FIFO principle. Let's talk about some useful methods of stacks. To push onto a stack means to add to the stack, basically adding a coin on top of the stack. So it's like append for a list. Pop removes the item on the top of the stack. And that's a lot like the pop method for lists we've used in the past. But the difference is with the stack is, remember, you cannot identify an index when using it because it would violate the LIFO principle of the stack. Okay, now we're going to go ahead and demonstrate using a stack in programming. So I'm going to create a list. I'm going to call it a stack. Now, if we want to push items onto the stack, we can use the append method. So I'm going to go ahead and append a few items to the stack here. Let's go ahead and append our math textbook. And we're going to also go ahead and append our English textbook. And finally, we're going to append let's go for our science textbook. Okay, so now if we go ahead and print out our stack right now. Remember, we're still just working with a list, except we're going to force it to follow this principle. So you can see the first item we put into the stack was our math textbook. So that's now at the bottom of the stack. So if we want to pop something off of the stack, we're going to want to remove the last thing we put into the stack. So in this case, it'd be the science textbook. So we can say stack, and we're going to go ahead and pop. And that's going to remove the last item we put into the stack. And then if we go ahead and print the stack again, you will see that the science textbook was popped off of the stack following the LIFO principle of stacks. Now, let's go ahead and take a look at queues. So queues have two functions associated with them, enqueue and dequeue. So enqueue means to enter the queue. Dequeue means to be removed from the queue. Now, we also like to refer to the rear of the queue as where items enter, and the front is where items leave, just like you would a regular line, like at a supermarket. So let's go ahead and implement queues into programming. So I'm going to call it queue. I'm going to define it as empty list. And now I'm going to append, and instead of textbooks, we're going to use people, imagining like this is a line. So I'm going to append Bob to the front of it, and then I'll go ahead and append Alice. And then we're going to go ahead and append Jane to the list as well. All right, so now we have our items put into it. And if we want to go ahead and let's go ahead and actually print the queue just so we can see that. So here we go, we have our queue. So remember, Bob was the first person into our queue, so he should be the first one removed from the queue. So we want to go ahead and we're going to use the same pop method, although this is really the dequeue method. We're going to go ahead and access the queue, and we're going to say pop. But now we're going to pass in a parameter of 0, which is saying we want to pop the thing at the 0th index off of our queue. If we test that here, go ahead and print the queue again, you'll see that now Bob has been removed from the list, removed from the queue, rather, because he's the first one we NQ'd, so he's going to be the first one we DQ. Now, when we use lists like we have here, we're able to violate the principles of LIFO and FIFO. So for example, if I wanted to change this parameter to Q or to pop, I can change it to the first index, which would remove Alice, and our program would run, but that's violating the principles of a queue. So during class, we're going to teach you how to prevent this violation of the principles, as well as how we can actually sort these stacks and queues, because it seems as though we're only appending and removing from one end of the list. So we're going to go ahead and formalize it a little bit and do what's called a strict implementation of stacks and queues. Now, before you go to class this week, make sure you bring either a deck of cards or a deck of books, paper, Legos, or coins. And we're going to use these to help you understand a little bit better about how stacks and queues work with some physical objects. So make sure you bring some of those to your class. Your teacher will remind you about this as well. As always, if you have any questions, contact your teacher before class, and happy programming.